Good morning, everybody. My name is Walter Pizzini. I'm, as Steve said, VP of Pre-Sales and Professional Services for Expert System USA. First of all, I want to thank Steve and Ian for inviting me to this webinar. It's a pleasure and an honor to be here. Let's get straight into the subject. Ian and I have been preparing a demo where we show how the entity extraction capability of Expert System can be augmented by storing them into the AllegroGraph RDF store and linked to other linked data over the web. Let me give you a brief introduction of Expert System and what we do and the entity extraction part, and Franz will, and Ian will take it from there and talk about the RDF store and the rest of the demo. So Expert System has been a leader in semantic software for the last 20 years. You can see some data on the slide, and practically we are an international company with most of our presence in the United States and in Europe. We have around 1,000 employees, and we pride ourselves to invest a lot of money into R&D. So we're passionate about semantic technologies, and that's what we like, where we like to invest our money. This is a quick view on a few of our customers around the world. You can see that many of those are in Europe, and a few of those are in the United States. We have a presence in different application areas: knowledge management, customer care, corporate intelligence, mobile, and homeland security. And just to give you a brief introduction on how what our core technology is and what we do at Expert System. Our core technology is based on the fact that we take any type of input, and you'll see that during the demo that Ian will be showing you later. We take any text input, we process it using our Cogito technology, and then we are able to produce a structured output in an XML format that can be used in a lot of different applications. This is what normally we call entity extraction. Our differentiator compared to our competition is the fact that our Cogito technology uses a semantic net to be able to disambiguate the meanings of, or the words that are ambiguous. And so really the capability, as we do when we read a piece of text, to understand it, to make sense of it, and to be able to extract very important information from the text. You can see on the right of the current slide that we build a lot of applications and solutions on the top of the Cogito core technology, and the ones that we're going to focus on today is the automatic tagging and extraction. Okay, let me give you a quick demonstration of what I mean by entity extraction. Let me clean up. Okay, let's go on Google News, for example, and that's what we do in the following demo. That we do on text. And so you can find all kind of information. You can find information from grammatical information with logic analysis, and we do what we call semantic analysis, where we're able to disambiguate ambiguous terms and understand what they mean, what they really mean. Now let's have a look at what is, I think, important for this demo. Some of the entities that Ian will be showing in the next demo is about people, organizations. We can extract dates and money amounts in a normalized form. We also extract places. You can see New York and San Francisco mentioned in this article. The other thing that I want to show you from this demo is the fact that we extract, obviously, as I showed you before, some default generic categories from the text. And interestingly enough, also we are able to extract the main concepts, where by main elements or relevance, as we call them, we mean the concepts that are mentioned into the text and that are the most important, the most relevant inside the text. So in this view, we are able to see that this article talks about loan and bank, definitely about Wells Fargo, and we give you a score for each of those concepts and how important they are inside the text. This is not based on frequency. I want to point that out. This is based on the semantic importance of those concepts inside the text. So going back to the presentation, I just want to, before passing the control to Ian, I want to show you a little bit a quick diagram about the demo that Ian and I have been building. You can see on the right-hand side that we are downloading articles from Google News. There's a crawler. The gray components that you see here are the components that Ian and Franz have been developing, and Cogito discovered the red-brown box at the left bottom side is the expert system component. So the crawler basically crawls articles from Google News. It sends them to Cogito Discover. Cogito Discover takes the text in input and returns the entities in an XML output format. The crawler then stores them into the AllegroGraph RDF store, and the Graph RDF browser is the entity that is able to give you a unique view of data extracted from Cogito Discover from the articles, and also the linked data cloud on the internet. And from this very generic diagram, I'll leave it to Ian, and Ian will go into a lot more details.
All right. Okay. So let me start with a few slides. Let's see, where's the Windows 7? Oh yeah, here it is. So as you saw in the previous slide, we take data from Cogito, put it into AllegroGraph. A little bit more about the data sets. What we do is we scrape Google 3 times a day. Google News. You look at all the main categories in Google News. This is just the top, but there's also, of course, on the left-hand side, world, U.S., business, science and technology, entertainment, sports, etc., etc. And then within each category, we take the subcategories. So let me go back. So you see just in the top here the most important categories within the top stories, but each of these has a few subcategories. Then within those, you take 5 different files, and they go through Cogito into the Triple Store. Now what I've done so far is we take the people, and we just saw the people in the Cogito demo. The RDF predicate that I give it is has people, and we also look at the roles. We take the places and the county, state, and country they're in. Usually we get organizations from an article, so we take these in. Then this is probably a slightly unfortunate name, but what we just saw is that Cogito is capable of taking the main categories of a particular text, and so I'll take the ones that have a higher than 1% of these categories, and I'll put them into triples, because there's a lot more usually, but I'm only interested in the ones that have more than 1%. And then there's the important concept, important nouns and phrases in the text, and we looked at that too, and I've turned those into triples. So what I'm going to demo you now in Graph, our visual interface on top of AllegroGraph or Triple Store, is we'll look at some of the main properties of a text. I'll show you how I can find all the information in my Google scrape just by using full text indexing. I will do very simple Sparkle and Prolog queries on top of the text. I will show how you can use a Triple Store to find related articles, and then I'll have some fun with finding connections between different concepts. So let me go to the demo first. So where is my, oh, that's it. Where's my, here it is. Oops. Here it is. So here's the screen. The database is already open. And let's just start by finding some articles. So I can use free text. So I took this Google scrape. I take one scrape that I did about 3 weeks ago. It's about 600 articles, and every article gets full text indexed. So I can take whatever I want, but in this case I take Obama and Geithner. And what I see that there's 3 texts that mention both Obama and Geithner in the text. So let's take them here. So now they're on the screen. This is the graph view, but if I want to, I can look at, I hit the T here, and now I am in the tabular view. And let me take you through the triples that you see here. So here are the main categories that Walter was talking about. So this one particular text is about ministries and ecology, economics, energy, finance, and politics. By the way, if I click on any of those, I get all the texts that are actually about ecology. Let's go back. Then let me skip here. So here are the most important nouns and phrases that Cogito found in the text. So this one is about renewable energy and job growth, development. There's some organizations, the Department of Energy, Department of Treasury, and the White House. There's a bunch of people in this text, and there are some places mentioned in this text. Yeah, so this is the main information. You see here a lot of relevance. If you do really large scrapes, then you probably want to leave them out, because this is every little statistics that you saw on Walter's screen, but we have them here. So we see there's one relevance that's only about job growth, and it has this percentage for the score within there. This is the main category, and it appeared in this particular text. But you probably want to leave that out if you do really large data sets and just get the main categories. So I go back to the, oh, let me go back to the tabular view. So you see this here. So so we also have the full text in the article. So this is the text that we got. And this is also very wasteful, but we have all the XML that actually gets returned from Cogito. So that's the main information that comes plain in Triple Store. Let me go back. And I clicked on some links, so now you see multiple links. So I'll take Graph back a few steps. So here were the original 3 articles, and say let's explore these texts now graphically. So I'll only take the categories and the main nouns, and say the people and the places, and maybe organizations. Sorry, I have to do this again. And let me copy them from both to the subject side and the object side. And so now if I click on it, I see graphically that text 244 is about politics, and there's some other texts that are also instantly related to these ones, who are related through the White House again. And I could click on basically anything in this text, and I could go forward, say let's click on this Stephen Chu, and I get some more relationships. I could click on renewable energy, but there's nothing more about this. I'm always afraid to click on Barack Obama because I get too many links here. But there must be other articles that are about the Department of Treasury. Yeah, so this is one way to kind of explore your data. And if things get too complicated, you always can go back in this tool. And if you only want to see the things that are connected, I can hit Shift O in my tool and I see all the things that are basically deeply connected. Okay, so this is a little bit playing with the graph on the screen. Let's go back and let's do some queries. So let's first start with say load a query string and say find articles with 3 precedents. So I'm just assuming that the people in the audience are familiar with the Semantic Web and are a little bit familiar with Sparkle. So for example, here you say select distinct X, P1, P2, P3, where X is a person and P2 is a person and P3 is a person, and they're all precedents. Show me only the first 10 of these queries. So here I get a few results back, and if I want to, I can show them in a graph. But that's a more and better way to do it. And so I take another query and say is this query. And so what I do in the previous query didn't look at whether the P1, P2, P3 were really different. In this query, I actually want to find very distinct P1s, P2s, P3s who are all precedents. And so here we get a list of those. And now what you see is that this text had 3 precedents, and well, each of the pink text that you see has 3 precedents. Now it's not surprising that text 17 and 16 and 18 all have 3 precedents, because you might remember that I, per subcategory, read in 5 articles at a time, so it's kind of highly likely that they will be mostly about the same topic. And actually, we have a function for that to find relationships between articles. So I have one query that I can do, and it's, let me see, where is this? So here's a function that I can do where I can say find every article and the frequency of correspondence between articles and a title, and I find it for text 60, and I only want to know whether they are close together through this set of predicates, and only give me the first 10, and then for each article that I find also give me the title. Sorry, this is a complex query, but you get the idea. So I evaluate this query, and now I get a bunch of results here. So what you actually see again is that text 60 here on the left-hand side has 17 links with itself, and then 10 with 62, 8 with 63, and 61. And of course, these are close together again because, as you remember, I was reading them in 5 at a time, so they better be closely related. But anyway, so this is how they link. Now I can create a graph from this again. So here you see the texts and the titles for each of them. And I could say, okay, let's see if I can find a link between these 2 articles. So I take text 60 and I take 63, and I say, give me all the shortest path between the 2 texts. So I drag a line, and now you find that between text 60 and 63 you got a lot of connections. There's one through politics, there's one through law, there's one through foreign ministers, through institutes, through Israel, and the Likud party. Yeah, and so I could go on and on to find links between any 2 of the concepts. This one will be weird. Morning fix, the Mac attack is back, so let me take a link between this one too, and I go to this one, and then I see there's only a few links, only 4 links between these 2, because there's institutes, law, politics, and criminal law. Yeah, so this is one way you can use a triple store, Prolog, and Sparkle to kind of analyze your text. And this is only one scrape or one part of the day, so you can't do trend analysis over multiple days. But in our bigger databases, I can actually now look over many, many days and see changes in trends and follow people but that's maybe for a follow-up seminar. Okay, so far the basic usage of the output of Cogito into AllegroGraph, but let's continue. So if you look at the output of Cogito, it is kind of a self-contained closed world. Yeah, things have meaning, but only meaning in the context of Cogito. So one of the things that I would like to do, or that we did, was to take the output and embed it in the Semantic Web, or in the web of data. I guess most of you people have not heard about. I'm just assuming that everyone is familiar with the Semantic Web. This is from the front page of the W3C page about the Semantic Web. It's saying it's all about integration and combination of data drawn from diverse sources. And it's also about having a language for recording how data relates to real-world objects. And then everyone that has read about the Semantic Web by now has seen this wonderful picture of all the mostly open source, all open source databases that have been turned into RDF. In the yellow you see a lot of databases that are all about publications. Then there's even more information from biology. It's in the red. There's some social network analysis, social network data in the green, and there's a lot of multimedia information. But we actually linked in mostly with the stuff here. So we created links with dbpedia, Geonames, and with OpenPsych. So let me continue. So dbpedia is an RDF version of the Wikipedia, very, very rich in data, but a little bit light in ontologies. Then we have OpenPsych, which is very rich in ontologies, but light on instances. And then we have Geonames, which is a database that has about 7 million points of interest on Earth, from populated areas to mountaintops to post offices. And for each of the objects we have latitudes and longitudes. And we are also working on combining them with Freebase from MetaWeb. Freebase is a little bit like dbpedia, but much more elaborated. And the cool thing about Freebase is that you have unique identifiers for everything known to man. So I hope that in the future entity extractors like Cogito will not only give you the names of things, but also UUIDs that you then can link to things on the web. And they have standard vocabularies for the predicates, so it's a much more regular way to describe information. And then some other databases that we're going to link to. So I'm going to link to dbpedia, Psych, and Geo. So what we did is wrote software to link this, and I'm show you how that works, and I do a simple proximity search query to get a feel for how you can combine data from Google through all these databases and say do something interesting with geospatial information. So let me go there. Here is it. So let's go back to here and let's find something. Is there anything, Walter, that you're really interested in? Healthcare, swine flu.
Swine flu. Yeah, that's a pretty, that's something that interests everybody. Huh?
On that day there were a few articles about swine flu. So let's take them. Put them on the screen. So I can look at one of those. And for example, what you see here is two predicates, has LD name and has LD place. So far what you see here on the left-hand side are the things that you get directly from Cogito, except these two predicates were something that we added by writing interfaces to dbpedia and others. Actually, I've used mostly the triples of the Billion Triples Challenge. And so, well, let's just click on one. And then what we see is that this thing is related to a city called Alpha. Never heard of Alpha. In New Jersey? Yeah. And this is the longitude latitude of this place. It's a populated, PPL means it's a populated area. And it's mentioned in several other articles like in Text 190. So if we go back now, we see this particular place here. And let's just do something fun. I take now all concepts, all the predicates that we have for these things, and I could say, okay, how is text 190 related to next 490? I draw a line. Okay, so these are both about politics. There's still nothing. How's this thing related? It's probably not related. Okay, so this is probably that they talk about the same place. Yeah.
Mm-hmm.
Let's look at some people here. Yeah, so let me get a person. Let me see. No, there's too many links here if I show them all. Let's get some people in here. There's not many people in this in this text. Let's see here. Is there people? There's places. Oh, well, you chose something, Walter, without people. Let's go back and find some place. Find some people. Okay.
Mm-hmm.
Swine flu. Let's do healthcare. Healthcare. There's a lot of articles about healthcare. Yeah. Oh, let me. Sorry. Wow. So you're going to uncache everything. So let me do healthcare. Let's just get some text there. See if there's some people in there. Oh yeah, lots of people. Barack Obama. Okay, that's interesting. So let's take these people. Let me take LD name and the places. And now I'm linking directly from the text that we scraped to things in the data sets. And we find this information, say, about Barack Obama. Okay, show all. And so now we see how Obama is directed to text. But let me also, I also want to get to Barack Obama. Oh, here's the dbpedia raw for a person called Daphne. I don't know who this person is, but and so here you see that this person, Daphne, has wiki links, has a page on the web. Go back. Okay, there's a person called Samantha that is described. This person is described in the Wikipedia. He's worked in Florida, Lisbon, Portugal. He's NA. Anyway, you get the point. So we link both to the dbpedia, to articles in the Wikipedia. Now let's do some queries for this. So I'm looking at the queries. I load a query string and I say, for example, this query in Sparkle, where I say, okay, find all the texts and people where there's a text that has a person X and where this X has the WordNet type scientist. Yeah. So I do this relationship, I do this text, and I find 5 people. And so this is a query that actually works on top of both the Cogito results and the dbpedia. I can create a graph, and now we see, there's a bunch of scientists, and they're all related to particular texts. And I can then say, is there more relationships between 2 texts? And I would get more relationships. I could just go on and find how 2 particular texts might be related. And I can work from there. Let me do a geospatial query, and then I'll stop. So let me do load query string, proximity search. So one of the things that we have in AllegroGraph is a geospatial database with geospatial indexing. And so here I can say, find every Y name text where X has the name Boston, and there's a place Y within 30 miles of Boston, and then there is a text that has a name, and there's a text that has a name Y where Y has the name name. Yes, so there's an X, there's a place with the name Boston, and then there's another play within 30 miles, and then find all the texts that find this particular name and find the name. And I do this, and I get here a bunch of articles that are all about, well, this is actually the Geonames ID, the name of the place, and the texts. So I can take my hometown, Moraga, into the query, and so now I find, well, it's all about Stanford in this case, or whatever I want to do. If I do Washington, I'll probably get a whole load of articles. Yeah, now it's thinking. Looking, what you see here is most of the news is actually happening around Washington, obviously, in Google News. Okay, so that was actually most of what I wanted to show. Let me go back to the presentation. So yeah, I think that Walt and I want to thank the audience, and obviously, if you want to do anything that has to do with entity extraction and the Semantic Web, please just contact us. And I think it's now time to take some questions.
Yeah, there's a few questions. There's a two-part question from Walter's part of the presentation. I'll start there.
Sure.
This is going back to the extraction. You were showing us how you extract people, places. They want to hear more about that. And it said, can you explain a little how you extract those entities? What are the key methods?
Sure. Let me bring up. Can you give me the? Please. Is that okay? Yeah. So let me bring up this backup slide that I have. What we do the extraction that we do on text, we do things in 4 different phases. We do morphological analysis where we understand the headwords, like dogs and dog catcher is related to dog. We obviously do that analysis so that we're capable to understand the morphological parts of the sentences. We do grammatical analysis where we understand the part of speech, so nouns, verbs, etc. We do logical analysis where we understand the role of that word inside the sentence, and so we're able to understand whether a name of a person, for example, is a subject or the object inside the sentence. And these are things that also many of our competitors can do. But really the things that stands out for Cogito and expert systems technology is the semantic analysis. And by semantic analysis, we mean being able to disambiguate ambiguous words. So if you look at this example here on the left bottom side, we do we present a couple of sentences where we use the word stock, which might mean different things depending on the linguistic context where that word is used. Where we've invested a lot of time, R&D, and money is to be able to disambiguate it, to be able to understand that stock in the first sentence is related to cuisine and to cooking, and the stock in the second sentence is instead it's related to the inventory that a company might have. So completely different meaning. That's, by the way, something that is very trivial to humans, because when you read a sentence, that's what you do, without any particular effort. But this is something that needs to be implemented inside an algorithm and to make computers mimic the human brain behavior. And so a little bit of how we do it. We use something that we call a semantic net, which is similar to it is basically a huge graph of concepts that are specific to the English language. And so the way that we are able to disambiguate words that have the same, so concepts that are expressed by the same word, is by having a graph a huge graph where we have concepts and how they're related to each other. So I want to emphasize the fact that the links, so the way that they're related to each other is for us extremely important. So where you see we have 350,000 concepts and 2.8 million relationships in this graph for the English language. That is very important because when you want to disambiguate, what our parser really do is that, for example, for the stock example in the previous sentence, we're able to go and look at all the concepts that have a head word, so that are called stock with different meanings. And we have a look at how they are related in this graph to other concepts. And so, for example, if you talk about stock and cooking, you look at the sentence where the word stock is used, and you try to map it to the concepts that are linked to the word stock inside the semantic net. And this way, we're able to really make the difference between the word stock used in different concepts. This is extremely important when you try to do what we call deep semantic analysis of text, and you really want to grasp and understand the text that you're looking at.
Great. Here's another question. Again, a little bit of a follow on this. The entity extraction make use of an ontology, and if so, which?
I guess yes. I hope I kind of answered that question. We don't. The beauty of Cogito is that you do not need to build an ontology up front before you start analyzing your text. What we're trying to do is really to be able to analyze what we've done at Expert System. We've invested a lot of time and a lot of money to expand the semantic net in a way that it can make sense of text coming from different verticals, coming from legal, coming from so legal documents, news, blogs, text that emails, text that come from completely different contexts or environments. And so, although this is not technically an ontology, what I think is important to underline is that with Cogito, we have a huge graph that we call the semantic net inside Cogito that allows you to make sense of documents coming from different sources.
Okay, there's more. Related to the extraction process, can you extend the process to extract also specific entities, let's say animals?
Sure. And although many animals are already in the semantic net, so you would extract them out of the box, so you wouldn't need to do anything special about it. But most of the time when we go into especially big customers and big corporations, we find that they have their own dictionaries and they have their own terminology, their own jargon. And so what we are able to do at Expert System, we have tools that are able to inject customizations inside the semantic net. So we're able to customize that graph and make it specific to the customer without a huge expense. And we're able to inject any specific concepts that may be specific to the customer, specific to the vertical, or specific to the particular application that we're working on. We have already packs of entities that are specific to verticals. And in particular, one that I can mention is the oil and gas semantic net, which is a semantic net where we've injected a huge amount of terms that are specific to the oil and gas sector. And so we can do for any other vertical.
Great, great. Are you working in any other languages?
Yes, so that's a very good question. Cogito, being a deep semantic technology, is obviously the semantic net especially, and some of the linguistic rules that we use are specific to the language, so we're language specific. And well, the languages that we support today is English, French, German, and Arabic. And there are other languages that we're working on that are not released yet, and that will be available in the next year or so.
Okay.
We can give you more details if you want. You can follow up with me offline.
If one wanted to replicate the capability presented here, today, what's needed in terms of components and costs?
Say it again?
If somebody wanted to replicate what we've demonstrated here today, what are the components and costs?
Let's work on the components maybe first, which is, I think, the most interesting part. So in terms of, I can maybe come back to the slide that we had before. So if you look at this slide, you can see, I hope you can see some of the components that you need. You need a crawler. You need the AllegroGraph RDF store and the RDF browser. And I let Franz and let Jens answer that part of the question. For the extraction of entities, you just need the Cogito Discover component, and that it comes in the form of a process of a service that you can install. For the demo that I just showed, I have it installed on my laptop, so it's a very small but complicated component. And that component, so it can be installed on any machine, and the interface that you have available, and that most of our customers use, is a web-based interface, a SOAP interface that accepts an XML request with the text content and input, and it returns you an XML output with the information that you want to extract: people, companies, concepts, etc. I'll let Ian take it from there.
Okay, so yeah, for pricing information, you obviously we can send you an email with the price list. If you want to just play, there's an AllegroGraph that will work up to 50 million tuples, and graph is free. So most of for the RDF stuff, you can just start by just playing with it and trying it out. If you go to bigger numbers, then you have to call us. And even Cogito has some websites where you can send some data, get some data back, and just try it out.
Sure, yes. So contact us for this information.
So this, I think goes back to one of your slides. In this word disambiguation method, is there any way you could connect the disambiguated words to WordNet or any other dictionary?
Good question. WordNet is I must say the semantic net in concept, the concept of the semantic net is very similar to the concept of WordNet. So they're, in principle, they're very similar. You have concepts that are related to each other, they're linked to each other, both in WordNet and in Cogito. But I must say that although we started from a simple principle, I do strongly believe, and I've tested that, the fact that our semantic net is much more complete, and it is able to, it's basically a superset of the WordNet, meaning that it works on a lot of different verticals, and it has a lot more richness than the WordNet itself. Now, as opposed to, about the other sub-question that was, can you add dictionaries to the extraction? The answer is definitely yes, and that's what we do all the time. And what we do is that we have a tool that automatically is able to get those dictionaries from usually our customers, and we are able to inject them into the semantic net, and that way we're able to customize the outputs of Cogito with terms that may be specific to you. There is another component that I didn't show here that allows us to customize the output of Cogito, and that is a rule-based framework where you're able to build linguistic rules where you can find facts or events that are specific to your use, and you're able to inject those linguistic rules in Cogito so that you actually are able to do a much more customized extraction of events like, we can extract lesson learned, we can extract change of management, we can extract business events. That's some of the most common rules that we write and that we're able to inject in a way that you get a customized output with really the entities and the RDFs that you really care about.
So how or where did the WordNet synset for scientists come in? Is that part of Cogito?
No, The query that I did was, so I said I connected to the dbpedia, but what I actually did, I also connected to the billion triples challenge dataset, which contains the entire dbpedia. So, and the BTC also contains the entirety of WordNet. So while I was exploring the data, I saw that they also had included WordNet, and so I could do a query directly referencing that.
Okay, a follow-on came into the disambiguation. How would you disambiguate between two very related yet different concepts? Example, red camera versus red camera. Latter is a brand, former is just a camera of color red. It sounds like where there's...
So the example is red camera as...
Disambiguating between two very related yet different concepts.
Okay. And the example is red camera as...
Red camera versus red camera. One is just the color red, a camera, and the other is a brand name.
Oh, I see. Okay. Yeah, good question. We would... That is a tricky question, and that is something that is maybe based on a couple of things. So if you have a red camera where red is the brand, if I understood well the question, right? The red is actually the brand of the camera. Most likely there are linguistic rules that are able to make that difference. And so in the same way that you, when you read the text, make sense of that because you say, oh, red in this case is the brand because I know there is a brand of cameras that is called red. What we would need to have is inside the scintigrapher the knowledge of a brand or a brand called red. And then based on the context, on the linguistic context, we'd be able to understand if you're talking, if the red is just an adjective to the camera being of the color red, or if that belongs to a brand that that is in the semantic net called red that does camera products or photo related products. In the same way that we would base the disambiguation on two different means. One is the semantic net that we talked about in this slide, and the other one is on a set of thousands of rules that are able, based on the structure of the sentence, we call them internal linguistic rules, that are able to make sense of the sentence and understand those very specific differences.
Well, this is very, very interesting, Walter. I think we're about out of time now, so let's see if there's any more questions. We'll do one more. Is all of the facts in RDF from dbpedia and those Cogito extracted facts all stored as one graph?
Yeah. Sorry, see, I've got two versions. One is where I have 5 different databases next to each other, and one where I load them all in one big triple store. But you can run them all separately. So I have one version where I have the billion triples challenge next to the Geonames, next to Psych, next to the Google dataset, etc.
Okay. Was federation used in this?
Yes.
Yes. Okay. Again, I want to thank everybody for coming.